Okay, guys, we're going to start reviewing how to factor. Factoring is a big, important topic here in Algebra 2. It's also a great way to learn how to solve quadratics. Okay, so real quickly, let's start with a really basic, easy one. Let's start like this. Okay, so you have x squared plus 7x plus 12 equals 0. Okay, now we learned that to solve a quadratic, what we're looking for is x values that make the quadratic or the y value equal 0. Okay, so notice that this quadratic is set equal to 0. That's very important. They have to be set equal to 0 before you start to try to factor or to solve them in any way, but especially to solve by factoring. Okay, now it's kind of hard to think about, like if I asked you what number x that when you plug in here, first it gets squared, then you add 7 times that number, then you add 12. You want to know when that equals 0. Okay, that's hard to do mentally or to think about. So what factoring does is it creates a way for us to figure out which one of what numbers make this quadratic equal 0 in a lot easier way of thinking. So first of all, factoring is just undoing foiling. Okay, undoing foiling. So if we think about trying to FOIL these two things together, the first thing that we would do is do this, okay? And we're multiplying, so x times x would give us the x squared that we're looking for. Okay, so for all these problems that just have x squared in front, when you factor your two parentheses, just have that x, okay? Now, what we do to factor is we are always looking for two numbers that multiply to be the number in the back and add to be the number in the middle. Okay, if you can do that, then you will get this factored correctly every single time. So the two numbers that multiply to be 12 and add to be 7, okay, are positive 3 and positive 4. Okay, now what we've done, just so that you understand here, is that we've taken this quadratic and we've broken it up into a very simple multiplication problem. We have this first parenthesis, let's just first call it A, and we're multiplying that by the second parenthesis, let's call that B. And we need that to equal 0. Okay, now if A times B equals 0, just think about this. If A times B equals 0, then A or B has to equal 0 because 0 times anything is 0. Okay, so now to solve, what we want to use is what's called the zero product property. We take the first parenthesis and set it equal to 0 because when the first parenthesis equals 0, then that factored problem will equal 0. So I guess minus 3 here, and I get that x equals negative 3. That's my first answer. Then I set my second parenthesis equals 0 because when that equals 0, the quadratic will also equal 0. I'm minus 4, and I get that x equals negative 4. Okay, those are my two answers there. All right, let's do some more of these. Okay, so let's start out. Let's try this. Okay, so again, we just have x squared in front. So now I'm looking for two numbers that multiply to be negative 27 and add to be negative 3. If I'm looking for two numbers that multiply to be negative 27 or negative anything, one has to be negative and one has to be positive because a negative times a positive is a negative. Now, if they add to be negative 3, my negative number has to be larger. That way that when I add them together, the negative quantity still holds the greater value. Okay, so the two numbers that multiply to be negative 27 and add to be negative 3. Oh, whoops, sorry. I want this to be negative 6, sorry. Two numbers that multiply to be negative 27 and add to be negative 6, sorry, are negative 9 times positive 3. And now again, I just set these equal to 0 and solve. So I've got that x equals 9. That's my first solution. I set the x plus 3 equal to 0. I get that x equals negative 3, and that's my second solution. Now again, remember, this means that this quadratic crosses the x-axis at 9 and at negative 3. We'll do one more here. Let's go x squared minus 8x plus 12. So now I'm looking for two numbers that multiply to be positive 12 but add to be negative 8. If two numbers multiply to be a positive number, they're either both positive or they're both negative. Since these two numbers add to be negative 8, they must both be negative. So two numbers that multiply to be positive 12 and add to be negative 8 are negative 6 and negative 2. So that means when I set x minus 6 equal to 0, that my first answer, of course, is 6. When I set x minus 2 equal to 0, my second answer here is 2. Okay, there are two other types of factoring that we're going to work on doing today. Let me try to get some more screen here. Here, we'll just create a whole new fresh document here. Okay, when you're factoring, what you first always want to look for is what's called a GCF. A greatest common factor. Okay, so let's look at one like that. Let's say that we've got okay, now first one knows that this is a binomial, so this one must be factored a little bit differently. I should always look for a GCF first. The GCF is the greatest number that divides both 3 and 6, which in this case would be 3. Also, my first term has an x squared. My second term has an x. That means that I can take an x off of each of these. Okay, now I open up a parenthesis and collect what's left over. It was 3x squared. I took the 3. There was an x squared. I took one of them, so there's just a single x that remains here. Plus 6 divided by 3 is 2, and I took that x. Okay, now I still, in this case, use the zero product property to set the first factor, 3x equal to 0. When I divide by 3, I get an answer of 0. Set my x plus 2 equal to 0, minus 2, to get that x equals negative 2. Now, your factors, especially your GCF, doesn't always have to have a letter in front. So now we can try one like this. How about 2x squared minus 18 equals 0? Okay, if I was going to solve this one by factoring, again, I would look for the GCF, the greatest common factor. The largest number that divides 2 and also 18 is 2. Okay, I can't take a letter off of any of these because the 18 does not have an x to give. So now I open up my parenthesis. Okay, I took the 2, but the x squared is still there. 18 divided by 2 is 9. Okay, now I'll just set each one of these things equal to 0. Now, when I set 2 equal to 0, okay, that doesn't give me any answers. Notice back here on the last problem that we did that my GCF had an x in it. So since it had an x in it, I could set 3x equal to 0. I could solve for x. 2 equals 0, that doesn't even have a variable in it to solve. So that does not give me an extra answer. I can now, though, set x minus 9 equal to 0. Add 9. I get x squared equals 9. So then when I square root, I get that x equals positive and negative, because we always put that plus minus sign in front, 3. All right, last kind. Last kind. Okay, so another type of other type of binomial here, okay, is what's called a difference of squares. Let's write that down. Whoops. Difference or diff of squares. Now, what that means, okay, is that first of all, it's a difference, which means it's subtraction. And second of all, it's a subtraction of squares, meaning that each thing involved is what's called a perfect square, or something that is being squared. So here the x squared is, of course, the number x being squared. 36 is, of course, the number 6 being squared. And it's a difference because it's subtraction. It must be a difference. Okay, now actually what's happening here is that this binomial could be written like this. It's missing the middle term. So it could be x squared plus 0x minus 36. Okay, it's just missing that x term. So really, going back to the first trinomial way that we learned to factor, I'm really just looking for two numbers that multiply to be negative 36 and add to be 0, which of course would be positive 6 and negative 6. Okay, now the shortcut way for a difference of squares, once you recognize it's a difference of squares, let's go back to the top here. Okay, it's just to open up your parentheses and square root the front. The square root of x squared is x. Write that in front of each parenthesis. Square root the back. The square root of 36 is 6. Write that in back of each parenthesis. Make 1 plus and 1 minus. And then, of course, yes, we'll set these equal to 0 to solve. So I minus 6 here to get that x equals negative 6. I said x minus 6 equal to 0. I add 6 here to get that x equals positive 6. Okay, so the key is just recognizing that it is, in fact, a difference of squares. Okay, so that way you can use the little shortcut. I don't know why this isn't scrolling down anymore. That way you can use the little shortcut. And it won't erase. That's weird. Okay, that's all right. We'll just keep opening up another screen. We can get past this. Okay, so the reason why the shortcut is important is because sometimes they get a little more complicated, these difference of squares. So, like, for instance, what if it was something like this? 25x squared minus 81. So first of all, it's a binomial, so it's either a GCF or it's a difference of squares, okay? 25 is a square. X squared is a square. It does say minus, so it is a difference. And 81 is a square. So let's use our trick. The square root of 25x squared is 5x. Write that in front. The square root of 81 is 9. Write that in back. Make 1 plus and 1 minus. And now I'll just set each one of these equal to 0. I'll minus 9. Get 5x equals negative 9. When I divide by 5, I get that x equals negative 5/9. You could change that to a decimal if you wanted. That would be negative 1.4. I said x minus 9 equal to 0. I've got that 5x equals 9. So when I divide by 5, I get that x equals 9/5, which is positive 1.4. Sorry, 1.8. Sorry. All right, that's the introductions to factoring. Hopefully you'll catch on, ask me questions if you have them in class. See ya.